Welcome back. And I wanted to share with you a little demonstration that I've used in my online classes to help students understand hypotheses, variables, and how they work together in hypothesis testing. For our demonstration, we are going to use soda cans. And so the soda cans are going to represent our subjects in our study. In every hypothesis, you have an independent variable and a dependent variable. The independent variable is typically the one that comes first. It is the treatment, or it is the attribute that is present in your subjects that you are measuring. In our case, we're going to have a treatment variable. Treatment variable is one that is manipulated by the researcher. We're going to look at the effect of shaking a can of soda on the volume of soda that's dispensed when the can is opened. The shaking is the treatment variable, and in our case it's categorical because we are either going to shake or not shake the cans. The outcome variable is the measured variable. It's the dependent variable. The amount of volume that's dispensed from the can is essentially dependent upon the degree of shaking. When we talk about hypotheses, there are several different types of hypothesis, and every research study starts with a null hypothesis. The null hypothesis is essentially the hypothesis that is tested with the statistical test. Null hypotheses are based upon probability. A null hypothesis essentially states that a particular outcome is not expected, that there essentially will be no difference, no effect, or no relationship between an independent variable and a dependent variable. In this case, our null hypothesis would be that there will be no difference in the volume of soda dispensed from the can that is shaken versus the can that is held still. An alternative hypothesis essentially turns the null hypothesis around, and it states that there will be a difference in the can that's shaken versus the can that is not shaken. If we don't make a prediction in a certain direction, then this alternative hypothesis is known as a two-tailed test, a two-tailed hypothesis. Or the greater volume could occur in either the shaken can or the can that is held still. Hypotheses are often developed based upon theory or upon practice. Essentially, we know from our experience that shaking a can of soda does indeed affect the amount of soda that spurts from the top when you open it. We know that shaken cans tend to have more pressure inside. They do disperse volume once you open the can. So in our case, our alternative hypothesis would likely be the shaken can of soda will disperse significantly more volume upon opening than the can that is unshaken. That's our basic premise. What if we had a variant characteristic, however? What if one of our cans of soda was sugared soda and the other is diet soda? Do we truly know the effect of shaking and whether the shaking will be the same effect on the sugar soda as on the diet soda? In this case, we have an intervening variable, a moderating variable. What we could do is we could control for this variable in our design. We could shake as many cans of sugared soda as diet soda so that we offset the difference that might be brought forth by the type of soda. More often than not, we have other types of intervening variables in between the independent variable of shaking and the dependent variable of outcome, volume dispersion. Sometimes we know that those intervening variables can occur, and we know what effect they will have. At other times, intervening variables might occur without our understanding or knowledge. They might happen during the carrying out of the research study, and then we have to address those in our results section. In this case, I saw this demonstration from Steve Spangler, who is a science teacher and does little demonstrations on a local news channel in Denver. I know that tapping on the can help to alleviate the dispersion of volume after shaking. So we shake our can. Most people have learned that tapping on the top can stop some of the dispersion of the volume. But I know from Steve Spangler's little demonstration that tapping on the top doesn't have that much of an effect. We could try tapping on the top on certain cans. We could try tapping on the top on diet soda cans. But in Steve's demonstration, I learned that truly, to mitigate the effect of volume dispersion from a shaken soda can, one must tap on the side of the can. And one must tap all the way around the side of the can. Now, I'm not going to open the diet soda can or the untapped cans because I kind of value my electrical equipment. However, I'm pretty confident that tapping on the side of this can and then opening it is going to mitigate the amount of volume dispersed from a can that's shaken. That's a demonstration of a mediating variable that comes in between the independent and dependent variable that is controlled, that we understand can make a difference. I also know from Steve Spangler's demonstration that that same effect does not occur when one uses a can of diet soda. Therefore, I would not trust opening this can of soda with my equipment. I hope you enjoyed my little demonstration, and I hope that it helped clarify for you a bit about the types of variables that are present in hypotheses and the different types of hypotheses that one must have or one might have in your research study. Thank you.